Hello, everyone, and welcome to this presentation on easing in to material motion transitions. I am Nick Rout. I'm a developer advocate at Google, and I'm focusing on material design on Android. So today we're going to be looking at material motion and how to implement it on Android. And in order to do that, we're going to have a look at some different sections to break this topic down. We're going to start with the design system, an overall look at the theory behind material motion transitions. We're then going to take a look at a brief overview of the MDC Android implementation. We're then also going to introduce an example app. And in doing this, we're going to go to some practical examples of identifying scenarios where we can add material motion transitions to an existing app, how to implement them, and some things to look out for. We're then going to wrap things up and set some time aside for Q&A. So let's get going. First up, we're going to take a look at the design system. So from material.io, the motion system is a set of transition patterns that can help users understand and navigate an app. It's important to note here that this system in particular focuses on transitions. So this is navigation between separate screens in an app, or transitions between different elements on a screen or between screens. It doesn't cover other forms of animations, such as vector animations, or perhaps more low-level things like object animators or value animators. There's many ways to animate things on Android, but this in particular is focusing on transitions. So the four different types of transitions that make up these patterns are container transform, shared axis, fade through, and fade. They're designed to be used in a variety of scenarios that cover various aspects of navigation and transitions within your app to indicate relationships between elements on screens and also indicate to users the flow of an app when they're navigating through your UI. So to kick things off, we're going to take a look at the container transform pattern. This is for elements that have a shared container. A container is something like a surface or a background that is holding the particular element. And if a screen or perhaps two items on a screen have a relationship between them, transitioning between them using this container transform, which morphs between these two states, can really indicate that there's a distinct relationship to the user. Here we can see some examples of list items and widgets that are expanding into full screens. Alternatively, it could also be individual elements on the screen itself, like a fab morphing into a media player or a chip morphing into a card. The next pattern is shared axis. If elements do not have a shared container, but perhaps have what's known as a spatial or navigational directional relationship, the shared axis pattern can be great here. It's essentially a pattern that shifts items either on the x-axis, y-axis, or z-axis to indicate some form of direction. Here we can see some examples of an onboarding flow or a stepper, which are using x and y axes respectively to indicate that items are moving forward or back or up and down. The third pattern is fade through. If you're transitioning between two elements, but they do not have a relationship between each other, and you don't need to indicate that, the fade through pattern is a good pattern to use. It offers you a subtle fade and scale animation, but doesn't say to the user that these items are in any way related. In fact, it almost says that these are distinct while offering a smooth transition. Here we can see some examples of switching between high-level navigation destinations on something like bottom navigation, or switching accounts on an inbox screen. The last pattern is the fade pattern. This is for elements that are standalone. So you're not transitioning between, let's say, two screens or two elements on a screen, but just individual elements that need to appear and then disappear on screen. It uses, again, a subtle fade and scale to indicate this. Here we can see some examples of how this is used for dialogues, menus, and widgets like fabs and snack bars. Now that we have a brief overview of the theory, I'd like to introduce you to the material components for Android, aka MDC implementation of this system. It's available in version 1.2.1 and onwards. This is in fact the latest stable release of the MDC library at the time of speaking. From material.io, the library offers transition classes for these patterns built on top of both the Android X transition library as well as the Android transition framework. So the reason for this, and the reason that there are two distinct implementations of these of the motion system, is because this needs to support various different scenarios specific to Android. So there are classes that essentially map to these transitions, but there are two implementations of them in the transition package and then the transition.platform package. The transition package is recommended, and these are classes that are built on top of the Android X transitions, and they support fragment and view transitions. They benefit from backported bug fixes and consistent behavior levels, and go all the way back to API level 14. However, if you need to be doing activity transitions or window transitions, unfortunately, there's no backported support for transitions here, and so this is where you would need to use the platform versions of these classes. Just bear in mind that it's API 21 plus, and that you may see some inconsistent behavior across API levels. But together, these pretty much give you an implementation of material motion transitions for all different scenarios on Android. The four classes that I'm talking about they map to the four transition patterns that I mentioned earlier. So this is material container transform, material shared access, material fade through, and material fade. Notice the shared naming. Let's take a look at some examples of high-level examples of how you might use these in some common scenarios on Android. So here I'm going to show you a container transform between fragments using Jetpack navigation. The first thing you'd want to do in your fragments layouts is add a transition name. Here we're using start container and end container. And these two views in particular would be the ones that have the shared container that you're going to be morphing between. In our fragment B, we need to set a shared element into transition to a material container transform. In our fragment A, we would need to set an exit transition to a hold. This is also part of MDC Android and as a separate class. This essentially just holds the fragments view on screen while the shared element transition is running. Then, making use of Jetpack navigation's shared element support, we add extras to reference the start view to the end container. The next example that I'll show you is a shared z-axis between fragments. This is slightly simpler. In our onCreate block of our first fragment, we set a re-enter transition and an exit transition, setting it to a material shared axis, specifying the z-axis, and then specifying the directions. Similarly, in our second fragment, we would also do the same, but the directions would be different. Next, I'll show you a fade through between fragments. And this is even simpler. We're simply setting an exit transition as a material fade through on our first fragment, which will be disappearing, and an enter transition as a material fade through on our second fragment, which will be appearing. Last but not least, I'm going to show you how to fade a target view using the transition manager and using the material fade transition. It's quite simple as well. We simply declare a material fade transition, use the transition manager to begin a delayed transition on the overall container of our fragment, or where we want to be running this transition, specify the fade, and then adjust the visibility of the particular view that we want to be fading in or out, depending on whether we want to hide or show it. That was a brief look at some very high-level examples of how you might go about implementing transitions using material motion on Android. If you've dealt with transitions on Android before, it should look quite familiar, especially Android X transitions. Just slightly different class names, but it's pretty similar to shared element transitions or just regular Android X transitions between fragments, activities, and views. However, I'd like to introduce an example app where I had to identify scenarios where I could add material motion to certain flows or screens in the app and implemented, and then came across some caveats that I think you should be aware of. The example app is called Rugby Ranker. It's essentially an app that shows you rugby rankings, fixtures, and news. It's available on GitHub and also on Google Play. It makes use of things like 100% Kotlin, pretty much all architecture components libraries, and of course, MDC. There are a few flows in the app which I identified, which I thought would be good for implementing material motion. So when I built this app, I figured I would use Jetpack navigation and rely on the default animations that come out of the box with this library for fragments and dialogue fragments and so forth. Once I'd done that, I went through certain flows to figure out where I might want to add material motion. So here we can see that the top level navigation element is a nav drawer. And when switching between them, it relies on the default Jetpack navigation alpha animation that's fading out the outgoing view and fading in the incoming view. It's not bad, but it is certainly a case where I think we could be using something like a fade through transition, because there isn't a relationship between the top level screens, but we want to get that sort of nice scale and fade that we saw from the fade through material motion transition. The next flow, which is the main flow within the app, is adding a prediction. So this is when you would add a match and then see how the rankings would change. The main thing to note here, though, is that there are two elements on the screen that are definitely related. There's the fab, and there's something known as the prediction bar. They clearly share the same container color, which is that blue secondary color, and the plus icon. They only differ in the fact that the prediction bar includes a list of chips that show your current predictions. So in this case, I think it would be a great example or a great scenario where we could use a container transform. Lastly, on our settings screen, we have a theme dialog. So this essentially allows you to pick your dark mode theme that you'd like for your app, light, dark, or system default. And once again, it's just using Jetpack navigation to show this dialog fragment and using the bundled or the default animations, which appears to just be a fade in and out. So here, despite slightly confusing naming, we'd use the material fade because I think it could benefit from that scale, which would add a little more polish to this experience. So now we're going to have a look, now that we've identified some key scenarios where we could add material motion, let's look at some practical implementations of material motion in these three separate flows in the app. Starting off, we'll take a look at the fade through transition, which is going to be for our top level navigation destinations. We have three classes in the app. There's sport fragment, which houses all of the rankings, fixtures, and live scores. There's news fragment, and there's info fragment, which is our settings screen. We don't have anything added here yet actually related to transitions. We're basically just using the default Jetpack navigation fragment animations as I mentioned earlier. But let's change that. In all of these fragments in our onCreate block, we'd want to be adding both an enter and exit transition and specifying a material fade through. We'd want to be specifying both enter and exit because switching between these destinations can happen in pretty much any order. You could be going from sport fragment to info fragment to news fragment, and then news fragment back to info fragment. And in all of these cases, you'd want the outgoing fragment to fade out, or fade through out, I should say, and then the incoming fragment to use fade through in. So now that we've added these to each of these fragments, how does it look? Well, when we take a look at it, it doesn't really look quite right. The info fragment appears to be animating to an extent, but if we slow it down, we can see that the news fragment certainly isn't, and there's a strange effect happening where the text of the info fragment is left fading out over the news fragment. And this definitely isn't right. This doesn't look like the fade through animation that we saw from the design theory in the beginning. So what's going wrong here? As it turns out, we actually need to do a couple more things to get this to run correctly. Firstly, in each of our fragments layouts, we need to set Android transition group to true. This attribute ensures that the transition is applied to the screen as a whole, as opposed to individual views within the hierarchy, which can cause the transition framework to get a bit confused. This attribute is available from API 21 onwards, but there is a compat version of it available, which can be used programmatically. Secondly, we want to include these two lines of code in our onViewCreated block in our fragments. This essentially postpones the enter transition and then starts it just before, just when on pre-draw is running. And this postpones the enter transitions and allows them to run smoothly and choreograph together. Once we've added them, we'll see that this is now looking a lot better. Our news and info fragments are smoothly switching between each other with the material fade through that we have seen before. However, while this is working correctly and is certainly the default, when I looked at it, I thought to myself that this is looking a little bit fast and that I'd like to tweak the duration of the animation slightly. And with the MDC Android implementation of these transitions, you can do just that. So in addition to the default material fade through transition, which I applied, I specified a transition duration value, which is just mapping to a default Android value of 400 milliseconds. I'm using an apply block to add these to both of my material fade through transitions. And voila, in my opinion, looks quite a lot better. I think the slightly longer duration, as opposed to the default 300 milliseconds, choreographs a bit better with the sliding out navigation drawer. That's our material fade through transition complete. Let's move on to our container transform. This one's pretty exciting in my opinion. So in our sport fragment, which houses both our fab and our prediction bar, we have the following code already, which basically fades out the fab and fades in the prediction bar when you add predictions, and then when you clear the predictions, it fades out the prediction bar and the fab fades in. It's a fairly simple bit of code. We're specifying a default Android X fade transition. We're using Transition Manager on the overall root layout of our fragments. And then we're adjusting the visibility of both of these two widgets depending on some logic. But we want to change this to a material container transform, and we want to get that nice shared container relationship and transition that we saw earlier. The first thing we need to do is change our transition from a fade to a material container transform. The one thing that we're setting here is a scrim color to transparent. This scrim color is essentially all of the space around the shared container that animates along with the shared element transition, the material container transform. Usually you'll see like maybe a semi-transparent black color, which just adds to the overall overall polish of the animation. But this is better for screen-to-screen transitions. In our case, because we're transitioning between two views on a screen, we don't actually want to have the scrim because that would then obscure the content behind the fab and the prediction bar. So we set this to transparent. The next thing we need to do is add a target to this transition. In our case, we're using the fab. This prevents the container transform from running on both the start and end view, which can cause some jank. Lastly, using similar logic that we use below for setting the visibility of the two widgets, we use some logic here to essentially set a start and an end view, which happens to be either the prediction bar or the fab or vice versa. I'd like to note here that the code below involving the transition manager and visibility of these two views remains the same from our original implementation. That just stays as is. Now that we've implemented this, how does it look? In my opinion, pretty good. There's now a clear relationship between this fab and this prediction bar. When we slow it down, we can see how it choreographs really nicely and smoothly animates between the two states, giving you the sense that this is despite the fact that they're two separate widget classes, that they're one and the same. However, as with before, I looked at this and thought to myself, it feels a bit fast in real time. And there's something slightly snappy about it. I guess that's Maybe not the best word, but that's how it felt when I first looked at it. So again, I went into how I might customize and tweak the values of this to refine the experience. I added 3 things. Firstly, as with before, I changed the duration to this 400 millisecond value. Next, I adjusted the interpolator. This essentially changes the easing of the animation so that it's a bit smoother as opposed to linear. And in our case, we're using a fast out, slow in interpolator. There's a bunch of interpolators available. It's quite an in-depth topic as to which one you should use, but maybe chat to me about that afterwards. The last thing we did was set a fade mode. There's a bunch of these fade modes, which essentially fading and changing the alpha values is one of the aspects of a material container transform. And in my case, I only wanted to fade out the outgoing content without changing the opacity of the incoming content, which when I slowed it down, looked a bit better. And the final implementation, while the differences may be subtle from what you saw before, do feel a bit smoother to me. Slowing it down kind of looks about the same, but in real time, I think it looks a lot better and choreographs really nicely with the recycler view diff animations that you see happening on the ranking screen. That's our container transform transition complete. So let's move on to our final one, the fade transition. This is going to be on our theme dialog fragment. So in this class, as with the other example, we don't have anything added here yet. We're just using default Jetpack navigation dialog fragment animations. So nothing too interesting to see in our initial implementation. The first thing I tried was with my other fragment example, inside my dialog fragments on create block to set an enter transition and exit transition to be a material fade. As it turns out, this didn't work. The next thing I tried and the next idea I had was to perhaps grab the dialog that backs the dialog fragment, then get access to its window, and using those platform classes that I mentioned in the beginning, set the enter transition and exit transition on the window instead. But this also doesn't work. As it turns out, we can actually only apply animations to an alert dialog via window attributes in a theme overlay. But the problem in my case is that these MDC Android transition classes, as I've shown in all the other examples, can only be used programmatically. You can't specify them, let's say, in XML or put them in a nav graph or something like that. They're pretty much exclusively used programmatically. So what can we do here? In my case, the only option I was really left with was to make an XML version by following the material spec and then inspecting the material fade.java source code. I know it sounds a little scary, but let's go through it because in the end, I think it worked out pretty well. The first thing I did was went to material.io and looked at the motion system spec. We need to make an XML version of material fade in and out. So fade in has a few specs that are mentioned here. It scales from 80% to 100% of its size from its center point for 150 milliseconds. Then it fades from an alpha of 0 to 1 for the first 45 milliseconds. By inspecting the material fade source, I saw that they were also using a fast out, slow in interpolator on the entire transition. So let's go about implementing this as an XML animation. First, we specify a set in our res and a new file material fade.xml and a set which has our interpolator, which is fast out, slow in set on it. Then to this set, we add our scale animation, which is going to take our X and Y scales from 80% to 100%, pivot from the center point, which is 50%, and run for a duration of 150 milliseconds as per the spec. The next thing we'll want to do is then add our alpha, which adjusts from 0 to 1 for the first 45 milliseconds. And that's our fade in animation in XML form complete. The next thing we want to make is the fade out transition, and this happens to be quite a bit simpler when we check material.io. All it's doing is fading from 1 to 0 just for 75 milliseconds, and again, using the same interpolator. There's no scale here involved. So again, we make a new file, material fade out.xml in our res/anim directory, create a set with our same interpolator, and add our alpha animation 1 to 0. And it runs for 75 milliseconds. Now we're getting into alert dialog territory. We've made these two raw XML animation files, but we need to bundle them together into a style. So in our case, we need to do this here, and we've named it accordingly, extending from the Android animation base style. We reference these two files that we made, material fade in and material fade out, using the window enter animation and window exit animation attributes. We've now bundled this into a style. This style then needs to be referenced in a theme overlay. I've made a theme overlay here that extends from theme overlay.material components of material alert dialog, because I'm using material alert dialog to show or to build all the dialogues in my dialog fragments. Important to note here is the window animation style attribute needs to point to the style that we made previously. Almost there. The final thing we need to do in our apps theme, the one that we would set on our activity or at an application level, is use this attribute material alert dialog theme and point it to the theme overlay that we just made. This will apply these animations to enter and exit animations to every material alert dialog in our app, which I wanted. But if you want to use it on a per case basis, if you use material alert dialog builder, there's a secondary constructor which accepts a theme overlay resource ID. So with all that done now and all that XML coding we've completed, how does it look? In my opinion, pretty good. It matches the default spec. I didn't feel that it needed any further adjustments or tweaking of values, and I was really happy with how it came out. Although I didn't use the material fade programmatic class from the MDC library, I was fairly easily able to recreate it in XML and apply it to all the dialogues in my app, including this theme dialog. So we've been through adding a bunch of transitions to our existing app. We've had a look at the design theory, we've had a look at some more generic examples, but also some caveats and some things that you need to be aware of, I think, in the real world when you actually end up using this. Our final implementation, in my opinion, I think looks really good. These transitions individually perhaps may seem not that significant, or that they're like a small thing that you're adding to your app. But when you combine all of them together, in our case, container transform, fade through and fade, and then add in other things like sliding sheet animations, recycler view diff animations, even such things as vector animations, and so on and so forth. It really lends itself to a smooth, fluid user experience. It clearly indicates how users navigate through your app and the relationship between certain elements and screens that make up the overall flow. I think it's looking really good. Of course, there are some more resources that are available to you. There are official docs and samples on material.io in both the design and develop sections of the website. I would also suggest that you check out the MDC Android catalog app. This is available on the MDC Android GitHub repository. And if you go catalog/transitions, or just clone that repository and run that in on your phone, you can take a look at some of the various options that they have there. Recently, we've published a whole bunch of content under the name Building Beautiful Transitions with Material Motion for Android. Currently, it's in the form of a code lab and a blog post, and we have a video coming out on this soon. This goes through a similar process how I did with my app, with a material study app called Reply. And that's that. We've been through a whole bunch of stuff related to material motion, adding it to an existing app, and some things to be aware of on Android. I'd like to thank everyone for attending my talk, and would like to open it up now for questions from the crowd. Okay, have a look at the questions now. First one's from Dave. Any resources you'd recommend for developing a better sense of what, how to tweak to make them more pleasing as you've done here? I know there's guidance on material.io, but that's the spec that you're tweaking, right? The out-of-the-box transitions. It's a really good question. I'm not sure I have a solid answer for this. In my case, I am the sole developer, designer, everything on my app. In many cases, though, I think you may have access to designers on your overall team or at your company, and I think they might be good people to consult, because this, tends to perhaps come into UX design and UI design overall. But at the end of the day, for me, it was a case of seeing how it feels. And in particular, what helped for me was the developer option on Android, which allows you to slow down your various animation scales. If you haven't seen that already, it's in developer options, and you can also get a quick settings tile for it. But that really helps if you want to really fine tune and adjust how it feels. In terms of the actual theory of what gets it just to feel right, I guess I'm a little bit unqualified to answer that question. I mainly did it by feel and what I thought felt right for me. So I hope that answers your question. Yeah. What effects does this have on UI performance? So considering that it's built on top of the existing Android X transition library, not a whole lot in most cases. Initially, when the library launched, there were a few performance issues with especially the material container transform, because it's quite a heavy calculation of shifting and morphing between these two states. But as of 1.2.1, a bunch of those performance issues are squashed. So I think it's fairly minimal these days, and I haven't noticed anything myself, especially in my production app. Are these animations coming to Jetpack Compose? Great question. I believe the intention is yes. The actual timeline of such, I am not aware of, and I don't really know. I don't think I'm really qualified to answer this question right now. But at the very least, I know that Compose is committed to implementing the material spec as a whole, and of course, motion forms part of that. So definitely at some point. When, I can't say for now. Okay, the next question is, hey Nick, for Jetpack navigation transitions, did you leave these in the nav graph or replace them with the MDC programmatic definition in the fragment? So I actually didn't specify any animations in my nav graph. You can, using Jetpack navigation, with all these like enter, re-enter, exit, I think those are the name, pop, exit, pop, enter, XML animations. I didn't use that at all. There are default animations that come out of the box, which is that fade if you don't do that. And in the case where I had to build the XML version of material fade, actually those animations don't work with dialogues in Jetpack navigation there as well in the nav graph too. So there's pretty much, it's quite a dialogue fragment is quite limited in how you can apply those. So that was the only way that I found that could work. But yeah, I didn't have any initial Jetpack navigation transitions applied. What is the view component that the fab animates into when tapped? From Anonymous. That is a custom view that I made. It's called prediction bar. It is a compound custom view which includes a card, a recycler view, and a recycler view that hosts a list of chips, an icon, which is the plus button. It's essentially a custom view, but the source code for it is available on my GitHub repository. The class name is predictionbar.kt. So you can take a look at that. It's not too complicated, but yeah. Do you have any advice on implementing transitions from when adding/removing views to existing view groups rather than switching between top-level fragments/view groups? Yeah, so in this case, in my experience, that's when using something like the transition manager, setting up a transition and using the transition manager and setting target views is where you would want to start. Adding and removing from view groups is something I haven't tried, but in most cases, I started with an XML layout that includes all of the views that I may want to transition between. With some kind of default visibility, like pretty much all of them are gone and the one is visible. And then transitioning between them is a case of setting up a transition, giving it to transition manager, and then adjusting the views of the relevant, adjusting the visibility of the relevant views, and that just seems to work out of the box. I imagine that having a similar approach when adding or removing from view groups would work, but personally, I actually haven't tried that. Carla says, I had issues with shared element transitions between activities. The second activity appeared very slowly. Did you experience something similar? I didn't, because I don't have any activity transitions in my app. I have a single activity and just use fragments. First thing I would ask is which version of the library are you using? 1.2.1 included a lot of performance and bug fixes from 1.2.0. So my first suggestion would be to bump to that if you aren't on that. And if you're still experiencing it, I would suggest creating an issue on the material components MDC Android GitHub repository, and ideally with some reproducible sample code or projects so that we can take a look. Osama says, is there a tool for designers to build these animations only by design so they would be technically possible to implement by developers using MD Motion guidelines? A part of me thinks it's a yes. I'm pretty sure there is something. I forget the name. I can get back to you in the chat room on talk about that. I just need to go and remember what that is. Yeah, let me send a link to talk if I can find it. Yeah. Enrico says, I think it's much better to implement transitions with XML to take separated UI and code. What's your opinion? Yes and no. I think for screen-to-screen transitions, it certainly can be beneficial and does take away a bit of cruft in your fragment code. But in some cases, especially with the container transform, where you need to do certain things programmatically, like the start view and the end view, and apply that based on logic, that's when you almost need to do it programmatically. I do agree, and in my case, I guess I had wished that there was an XML version of the material fade. So this sounds like a pretty good feature request for the GitHub repository once again. So if you feel like doing that, that would be appreciated. I've got a thank you. Doesn't look like a question, but I'm going to take that as all my questions are up. All right. See you in talk, and thank you so much again for attending.